Usually when humanity invents a new technology, there's like a natural rhythm to it.
Right, a progression.
Exactly. We invent the automobile and then we spend a few decades figuring out paved roads and stoplights and speed limits.
Yeah, you build the tool, and then you slowly build the infrastructure to handle it.
But when we look at artificial intelligence today, and especially generative AI, that natural rhythm is just completely gone.
It really is.
I mean, it's like we built a supersonic jet, put everyone on board, and only now, mid-flight, we're realizing, oh, wait, we haven't invented air traffic control.
Yeah, the human systems are entirely out of sync with the technological acceleration.
And to put that acceleration into perspective for you listening today, generative AI reached a 53% population level adoption in just 3 years.
Which is just staggering.
It is. For context, it took the personal computer over a decade to reach that kind of saturation. It took the internet even longer.
Oh, absolutely.
But despite this lightning speed, we are facing this, frankly, uncomfortable gap between what artificial intelligence can actually do right now and how prepared we are to use it.
I'd go so far as to say it is the defining tension of our current moment.
I completely agree. And we have two really fascinating 2026 sources on the desk today to help us map this out.
Two very different perspectives, too.
Right. First, we have the Stanford University HAI AI Index Report 2026, which gives us this sweeping macro view of the technology's capability.
Big picture stuff.
Exactly. And second, we have Docebo's the AI Readiness Gap Report, which is much more micro. It's a human-level view of how this tech is actually playing out inside our workplaces.
And the contrast is really telling.
It is, because both reports, even though they're looking at entirely different data sets, are screaming the exact same warning. So, okay, let's unpack this.
Let's do it.
Because to understand why you or your organization might feel so overwhelmed by this shift, we first have to establish just how fast and honestly bizarre the technology has become.
Bizarre is the perfect word for it, actually. Because if we look at the Stanford data, corporate investment in AI more than doubled in 2025 alone.
Doubled in 1 year.
1 year. And the models driving this transition are now almost entirely corporate products. Like, industry produced over 90% of the notable frontier models last year.
So the academic labs are just getting left behind.
Yeah, they historically drove AI research, but they simply cannot compete with the sheer financial resources required to train these massive systems anymore.
That makes sense. And the global race is getting razor thin, right?
Oh, incredibly thin.
The report explicitly states that the U.S.-China gap has effectively closed. I mean, in early 2025, China's DeepSeek R1 briefly matched the top U.S. model.
And as of March 2026, Anthropic's top model holds the lead, but by a margin of just 2.7%.
That is nothing. That's a statistical rounding error. But here's where it gets really interesting for me. Regardless of who is building these models, they are all developing what researchers are calling a jagged frontier.
Yes, the jagged frontier. This is crucial for understanding why interacting with this technology can feel so disorienting.
Right, because the report shows these AI models are effortlessly passing PhD-level science questions. Like, a model called Gemini DeepThink literally won a gold medal at the International Mathematical Olympiad.
A gold medal against the smartest kids in the world.
Exactly. Yet, that very same top-tier model can only read an analog clock correctly 50.1% of the time.
It's basically a coin toss.
It is. And when they integrate this AI into physical robots, the robots fail 88% of basic household tasks in the real world.
Even though they had an 89.4% success rate in software simulations.
Which is wild. It's like having a brilliant but entirely sheltered idiot savant roommate.
Like
Someone who can effortlessly calculate the physics of the expanding universe, but absolutely cannot figure out how to load a dishwasher or tell you what time the pizza is arriving.
That analogy tracks perfectly with the actual mechanics of how these systems learn, though.
How so?
Well, we as humans, we naturally project generalized intelligence onto things. If you meet a person who can perform high-level calculus, you automatically assume they possess basic spatial logic.
Sure, if they know calculus, they obviously know how a clock works.
Exactly. But AI is not learning by interacting with physical reality. It learns by identifying unimaginably complex statistical patterns in massive bodies of text.
Oh.
So it can synthesize PhD-level chemistry because humans have written billions of words about chemistry. But reading an analog clock requires an inherent understanding of physical spatial reasoning.
Like a two-dimensional mapping of reality.
Precisely. And text prediction models simply lack that natively.
So they are incredibly intelligent within the realm of language, but just entirely blind to physical context.
Yes, and this jagged frontier makes the technology incredibly unpredictable. You don't know where the edge of the cliff is until you literally step off it. You ask it to write a Python script for a complex database, and it does it flawlessly in seconds. You ask it a basic question about the spatial relationship of objects in a room, and it completely hallucinates.
It just makes things up.
Totally. And this structural unpredictability is exactly why responsible AI benchmarks are lagging so far behind the actual capabilities.
I saw that in the Stanford report. They noted that documented AI incidents where AI behaved in unsafe, biased, or unpredictable ways rose sharply to 362 incidents in 2025.
The traditional safety nets are failing because the models are just so wildly uneven in their competence.
And it feels like if these models are getting this advanced and their underlying architectures are this computationally heavy, they have to be colliding with physical reality eventually, right?
We are hitting literal physical walls just to keep the lights on for these systems.
Yeah, the infrastructure demands are pushing the absolute limits of global manufacturing and energy grids. Like global computing capacity dedicated to AI has grown by 3.3 times per year since 2022.
3.3 times every single year.
And the geographic concentration of that computing power is a profound vulnerability. I mean, the U.S. is currently leading the pack with 5,427 AI data centers.
Which is more than 10 times any other country.
Right, but there is this glaring fragility in the supply chain because almost all of the leading AI chips, the physical silicon required to run those thousands of data centers, they're fabricated by one single company.
TSMC.
Yeah, operating out of Taiwan.
The entire global AI ecosystem is balancing on the manufacturing output of one foundry. The geopolitics of that bottleneck alone are just staggering.
It really keeps you up at night if you think about it too much. But it's not just the silicon either. It's the physical toll on the environment.
Oh, the energy consumption.
Yeah, the sheer volume of energy these systems consume is difficult to even wrap your head around. The estimated training emissions for Grok 4 alone hit 72,816 tons of CO2.
Wow.
And the power capacity for AI data centers reached 29.6 gigawatts.
To contextualize that number for you, 29.6 gigawatts is roughly equivalent to the peak power demand of the entire state of New York.
Just to run server farms?
Just for the servers, yeah.
And then there is the water usage. The report notes that the annual inference water use, like just the water required to process daily queries for a model like GPT-4o, could exceed the drinking water needs of 1.2 million people.
It's a massive physical footprint.
But wait, let's break that down, because a software program obviously doesn't drink water. Why does asking a chatbot to write an email consume a physical resource like water?
Well, it comes down to the actual mechanics of computing. When you ask that chatbot a question, you are triggering billions of transistor operations across thousands of servers simultaneously.
Okay.
And all of that electrical resistance generates immense physical heat. If you don't remove that heat, the silicon chips will literally melt.
So they need water to cool it down.
Exactly. These data centers use massive evaporative cooling towers. They pump in millions of gallons of fresh water, which absorbs the heat from the servers and then just evaporates into the atmosphere.
Wow.
So the AI isn't drinking the water, but the physical hardware is sweating it out just to survive the computational load.
Okay, so we have this massive physical ceiling dictated by power, water, and silicon. But the Stanford report also points out we are hitting a digital wall.
The data bottleneck.
Right, the data itself. Starting in January 2025, over 50% of all newly published internet content was AI generated.
Yeah, we're reaching what researchers are calling peak data.
Peak data.
The finite pool of high-quality, human-generated text on the internet is effectively exhausted. The web is just filling up with synthetic content.
Which raises an obvious question, I think. If the internet is now mostly AI talking to itself, can't we just use that synthetic data? Like, can't we just have the current AI generate billions of new data points to train the next generation of AI?
What's fascinating here is it seems like a logical workaround, but the actual mechanics of machine learning prevent it.
Why?
Because using synthetic data during the pre-training phase, which is the foundational phase where a model learns the basic rules of language, logic, and reality, it leads to a phenomenon called model collapse. Think of it as digital inbreeding.
Digital inbreeding? That sounds terrible.
Yes, because when an AI generates text, It is dealing in probabilities,
Yeah.
right? It's often shaving off the complex, nuanced edges of human language in favor of the most statistically likely output.
Okay, that makes sense. It plays it safe.
Exactly. And if you train a new AI on that smoothed out synthetic text, and then train another AI on that output, the errors and biases amplify with each generation. The model just loses its grasp on the diverse reality of human thought.
So it just gets dumber over time.
Basically, within a few generations, the outputs mutate and degrade into complete gibberish. You need fresh genetic material like authentic human data to keep the models tethered to reality.
Right.
Now, synthetic data does work very well in the post-training phase, when you are just fine-tuning a model for specific, narrow tasks. But the foundational reality, it must be human.
But since we are literally running out of raw human data to scrape, developers must be changing their approach.
They are. We are seeing a profound shift toward what they call data-centric methods.
Okay, meaning what?
Instead of simply vacuuming up the entire internet, garbage and all, developers are ruthlessly pruning, filtering, and curating highly specific data sets.
Quality over quantity.
Exactly. The Stanford report highlights a model called OMO 3.1 Think 32B. And to understand why this model is important, you kind of have to understand parameters.
Right, the connections in the AI brain.
Yeah, a parameter is essentially a synthetic brain connection. It's a computational knob the AI turns to calculate an outcome. Generally, the thinking was more parameters mean a smarter but significantly slower and more power-hungry model.
Right, the bigger the brain, the more power it needs.
But OMO 3.1 Think 32B has nearly 90 times fewer parameters than a behemoth like Grok 4.
90 times fewer.
It's a fraction of the size. Yet, it achieved comparable results on major math benchmarks.
Just by using better data?
Just through aggressive data deduplication and quality curation. They proved that if the data is pristine, you need far fewer computational knobs to achieve intelligence. Quality is officially beating sheer quantity, which, frankly, offers a real glimmer of hope for our strained power grids.
Yeah, no kidding. So, all right, we have this incredibly powerful, resource-hungry, somewhat unpredictable technology being optimized by the brightest engineers in the world.
Right.
You would assume that when this technology trickles down to the modern office, the corporate world is just reaping massive productivity benefits.
You would certainly think so.
But the reality in the cubicle is entirely different. Let's pivot to the Ducebo report, because it paints a deeply frustrating picture of how this tech is actually being implemented on the ground.
It's a very stark contrast.
Yeah. While 79% of corporate learning leaders say they leverage AI, 91% of organizations are completely stuck in the experimental stage.
Is playing around with it.
Exactly. Only 9.1% have actually integrated AI into daily workflows, and a mere 8% consider their use of AI to be transformative.
There's a systemic disconnect between the ambition of the C-suite and the daily reality of the workforce.
And the numbers from the actual employees are so telling. 85% of learners say the training they receive does not help them fully understand or use AI in their specific roles.
That's huge.
It gets worse. 1 in 5 haven't received any AI training at all. 79% say their learning isn't personalized. 78% say the training exists completely outside their daily software tools. And 56% simply say they don't even have the time to complete it.
People are just overwhelmed.
Reading through this data, it really feels like companies are buying thousands of enterprise AI licenses and just dropping them on employees' desks with zero context.
Yeah, pretty much.
It is exactly like buying a fleet of Ferraris for a city that has no paved roads and no gas stations, and then executive management sits around confused as to why everyone is still walking to work.
I love that. They are confusing tool access with actual transformation.
Yes.
And that Ferrari analogy, it really hits at the core of the issue. Organizations are operating on what the report calls a surface wave of isolated tasks.
A surface wave.
Yeah, like an employee might use an AI chatbot to summarize a PDF or write an email a bit faster.
Right.
That's tool access. But they are still plugging that slightly faster email into the exact same fundamentally broken bureaucratic workflows they had 5 years ago. They aren't redesigning the work at all.
They're just accelerating the busy work.
Exactly.
So how do organizations move past that surface wave? Because clearly, giving people a login isn't enough.
No, it's not. They have to dismantle the core structural barrier, which is how we historically measure capability in the workplace. Well, corporate learning and readiness are still overwhelmingly measured by completion rates. Did an employee click through the mandatory video modules? Did they pass the multiple choice quiz?
We've all been there.
Right. But completion rates tell you absolutely nothing about actual business outcomes or skill application. You cannot measure AI readiness with a participation trophy.
No, you definitely can't.
True readiness is entirely about whether a workforce can adapt their fundamental skills as the nature of the work changes around them.
Okay, so if generic compliance videos and basic chatbot training aren't working, what are the skills that actually drive that adaptation? Because the Docebo report offers a surprisingly clear roadmap here.
It does, and it might not be what people expect.
Right. The top priority for both learners and leaders over the next 12 to 18 months is obviously AI literacy. But it is immediately and closely followed by human skills.
Human skills.
Leadership, communication, critical thinking, complex problem solving. As the tools become more synthetic and capable, the most in-demand skills in the workplace are becoming fundamentally more human.
Because AI is essentially a high-performance engine. It can generate velocity, but it has no internal compass.
Right.
It requires human direction, deep contextual understanding, and moral judgment to produce actual lasting value.
And to cultivate those specific human skills, organizations have to shift to a concept the report calls skills intelligence.
It is a magic paradigm
Yeah.
shift.
Yeah, we have to abandon static course catalogs, the boring intranet page that dictates what management thinks you should know. Instead, companies are moving toward a dynamic AI-driven mapping of the skills an employee actually possesses and identifying exactly what they need in real time to execute their specific role.
This is where AI flips from being the problem to becoming the actual solution.
Yeah.
Like 45% of leaders are now planning to use AI for virtual coaching.
Virtual coaching.
Yes. This allows an organization to personalize learning and skill development at a scale that was previously impossible when you had to rely solely on the bandwidth of human middle managers.
Okay, wait, I have a hard time accepting that at face value, though.
Why is that?
Because if my company sets an AI loose to quietly monitor my digital output, track my capabilities, and then a virtual coach pops up to tell me how to be more human in my communication style, that feels less like skills intelligence and way more like corporate surveillance.
I hear that.
I mean, how is this not just Big Brother in a friendly, personalized wrapper?
It is a vital pushback. And honestly, the line between intelligence and surveillance is thin. It really is.
Yeah.
But the distinction lies in the application and the transparency of the system. The goal of genuine skills intelligence isn't to micromanage output or penalize workers. It is about removing administrative friction so humans can actually elevate their roles.
Okay, how so? Give me an example.
Look at the case studies in the report. Booking.com deployed automated AI systems not to monitor their employees, but to take the administrative burden off their learning and development team.
Okay.
The AI handled the scheduling, the personalized curriculum matching, the calendar invites, all the busy work, and it saved the team over 800 administrative hours a year.
Wow, 800 hours.
Right. And because those human educators weren't drowning in spreadsheets anymore, they were able to scale their high-value, face-to-face, instructor-led training from 20 offerings up to 120.
Oh, wow. So it freed up the humans to do the actual human work.
Exactly. Or consider SNCF, the French railway company. They utilized a platform called 365 Talents to dynamically map the underlying skills of 155,000 employees.
Mapping 155,000 people sounds like a logistical nightmare without AI.
It was historically impossible.
Yeah.
But by using AI to analyze work history and capabilities, they made the invisible skills of their workforce visible. The AI didn't replace human decision-making. It just provided a map.
And what did they do with the map?
Well, SNCF used that map to generate 100 million euros in savings through internal mobility.
100 million?
Yes, because instead of laying people off in one department and hiring externally in another, the AI identified employees who already had the foundational skills to transition into new roles with just a bit of targeted upskilling. It empowered the workforce to move.
So the technology acts as the lever, but the human is still the one deciding where to apply the force.
Exactly. As AI continues to reshape the economy, the models themselves will become commoditized. Everyone will have access to the exact same baseline intelligence.
Right. Everyone has the same ChatGPT.
Right. So the true differentiator, the ultimate competitive advantage for any company, will be the human beings who possess the critical thinking to contextualize that AI and the leadership skills to guide a team through the friction of transition. Skills intelligence simply provides a clearer map so you can apply your human leverage more effectively.
Man, what a journey today. We have traversed from the staggering macro scale, examining frontier models that require a supply chain bottlenecked on a single island in Taiwan, consuming enough power to light up the state of New York, and literally running out of human data to
It's a
ingest.
lot to take in.
It is, all the way down to the stark micro-reality in the modern office. The realization that none of that raw computing power matters if we lack the human infrastructure and the contextual skills to actually apply it. Buying the Ferrari is useless if you haven't bothered to build the roads.
Beautifully said. The physical infrastructure will continue to scale, but the human infrastructure is what will ultimately dictate the value created in society.
And for you listening, while watching the global tech race unfold is fascinating, your personal focus shouldn't just be on the newest model release or the latest benchmark score.
Definitely not.
It should be on cultivating your unique human skills, your critical thinking, your empathy, your leadership, and marrying those with these new synthetic tools.
I would leave you with this final thought, actually, drawing on the reality of that digital wall we discussed earlier.
Okay, lay it on us.
If we are truly entering an era where over half of the internet is synthetic, where content is endlessly generated by machines, and AI models are perfectly capable of executing rote analysis and processing data at light speed,
Yeah.
the most valuable skill of the future won't be writing code. It likely won't even be prompting AI. Instead, it will be human discernment.
Human discernment.
Yes, the rare, highly compensated ability to act as the ultimate editor, the sense maker, and the moral compass in a world that is, frankly, drowning in artificial information.
We need our traffic controllers just as much as we need faster jets. Thank you for taking this deep dive with us today. Until next time, keep digging.